In this video, we will continue learning heights and distances. Now, if we look at the question, he's saying that from 2 points A and B on the same side of the building. So suppose this is our building and there are 2 points A and here it is B. The angles of elevation of the top of the building are 30 and 60 respectively. So when you look at the top of the building from these 2 points, the angles of elevation is 30 and 60. So you have to choose which is angle 60 and which is angle 30. As you move towards the tower, the angles of elevation increase, and as you move away from the tower building, the angles of elevation decrease. So obviously this will be my 60-degree angle and this will be my 30-degree angle. So let's call this as C, this is D, and this is 90 degree. Fine. If the height of the building is 10 meter, now he has given us the height of the building as 10 meter, find the distance between A and B, correct to 2 decimal places. We have to find this distance. Let's call this distance as X and BD as Y, right? So what we will do using the data here, can we write, I'll take this triangle first, that is angle 30 degree first. Then this will be my opposite and this entire thing will be my adjacent. So I can write tan 30 is equal to this height upon this, which is 10 upon x plus y. Now I know the value for tan 30, it is 1 by root 3 is equal to 10 upon x plus y, right? Okay, let me cross multiply. What will I get? X plus y is equal to 10 root 3. Let me keep this equation as it is. This is my equation first. Now I will take this triangle and this time tan 60 will be 10 upon y, right? So what is my tan 60? It is root 3 is equal to 10 upon y. So if I cross multiply, I get 3 root y is equal to 10. So I get the value of y as 10 upon root 3, right? So what I will do is I'll substitute this value 10 upon root 3 in this equation in order to get the value of x, right? Let me do that. So I'll get x plus 10 in place of y. I'm writing 10 root 3 is equal to 10 root 3. Right? So here what I will do is I will shift this to this side. So I'll get x as 10 root 3 minus 10 upon root 3. Further, I can take root 3 as LCM. I'll get root 3 into root 3 is 3. 3 into 10 is 30 minus 10. So I got x as 20 upon root 3. Right? But I don't keep the irrational numbers in the denominator. So I will rationalize it. So let me rationalize it. I will get x equal to 20 root 3 into root 3 upon root 3. So this will be 20 root 3 upon 3. Root 3 into root 3 is 3. So further what I will do is I will substitute the value of root 3 as 1.732 because he has asked me to write the answer correct to 2 decimal places. So I have to replace root 3 divided by 3. So this will give me 20 into 1.732 is 34.64 divided by 3. So if I divide that by 3, that will be 11.34. So I have got the value of x as 11.34, right? Meters. Now the next one. He's saying that a shadow of a vertical tower AB on a level ground is increased by 10 meter when the altitude of sun changes from 45 to 30 degree, right? What is he saying? He's saying that let's consider that there is a sun here and the shadow of this vertical tower changes from, increases. When does it increase? When the angle of sun changes from 45 degrees, that is this 45 degrees to 30 degrees. So this distance increases by how much? 10 meter. When it changes from 45 to 30 degree, the distance increases, right? Shadow's distance will increase, right, by 10 meter. And let me say that this distance is x. When the altitude of sun changes from, okay, as shown in the figure. Find the height of the tower. Now I have to find the height of the tower. We are clear with the question? He's saying that this is the tower and when the altitude of sun changes from 45 degrees to 30 degrees, the shadow of the tower increases by 10 meter, right? So he wants us to find the height of the tower using this information. So I will first take tan 30 degree. Tan 30 degree means this entire triangle I have to take. So that is opposite, which is h, upon adjacent, that is 10 plus x, right? So tan 30 is 1 by root 3 is equal to h upon 10 plus x, right? So if I cross multiply, I'll get 10 plus x upon root 3 is equal to h, fine? Okay, let me use another triangle. In that I have tan 45 degrees is equal to opposite upon adjacent, h upon x. But I know that the value of tan 45 is 1. So 1 is equal to h upon x, cross multiply, x is equal to h. So you got the value of x as h. So what will you do? You will go back in this equation, replace the value of x by h so that you can calculate the value of h, right? Let's replace this x by h. So what will we get? 10 plus h upon root 3 is equal to h. If we cross multiply, we will get 10 plus h is equal to under root 3h. If we shift this h to this side, we'll get 10 is equal to root 3h minus h. So if we take h as common, we'll get root 3 minus 1. So my h will be 10 upon root 3 minus 1. Minus 1. So what should I do now? I will rationalize. So h is equal to 10 into under root 3 plus 1 divided by under root 3 minus 1 into under root 3 plus 1. Right? So my h will be 10 into under root 3 plus 1 upon 3 square is 3, 1 square is 1, 3 minus 1 is 2. So 2 fives are. So I got h as 5 into, if I replace this root 3 by 1.732 plus 1, what will I get? I will get h as 5 into 2.732, right? So what is 5 into 2.732? It is 13.660. So that is 13.7 meters. We have one more. He's saying that the angles of elevation of the top of the tower from 2 points on the ground at a distance of A meters and B meters from the base of the tower and in the same straight line with it are complementary. So let's read the question in parts. The angles of elevation. So there are two angles of elevation of the top of the tower. Let's make the tower. From 2 points on the level ground. So I have 2 points on the level ground. Let me make those. This is A and this is B. Right? A meters and B meters from the base of the tower. So this point A is A meters away from the base of the tower. Entire A's distance from this point let this be C and let this be D. In the A distance, A meters and B meters, and this distance from B to C, it is B meters, right? Is it clear? I read the question again. The angles of elevation of the top of the tower from 2 points. So 2 angles of elevation from 2 points A and B on the ground at a distance of A meters. So this point, capital A, is A meters away from this point C, and B meters. So this point is B, small b meters away from this point B, in the same straight line are complementary. Now he is saying that these angles are complementary. What does that mean? If you add these two angles, which angles? These angles of elevation, if you add them, they are complementary. It means that this will be bigger one, this will be smaller one. So if this is theta, this angle will be 90 minus theta because they are complementary angles. Prove that the height of the tower, that means let this be the height of the tower, is under root AB meters. Fine, this is our question. Now, let's start with tan theta. What is my tan theta? That means I have to take into consideration this triangle. H upon A. H upon A, right? Then, what is my tan 90 minus theta? It is H upon B, right? Now we know that tan 90 minus theta is cot theta. We have done the complementary angles. This is equal to H upon B, right? Now if I replace this cot theta by tan theta, how do I write this? 1 upon tan theta, because cot and tan are reciprocals of each other. Now I know the value of tan theta as H by A, so I will substitute here H by A is equal to H by B. So what will happen? This A will go here and H will be in the denominator, equal to H upon B. Now if I cross multiply, what will I get? H square equal to AB. So what will be my height? Under root of AB. That's what I had to prove. Prove that the height of the tower is under root AB meters. See how I have made use of the complementary angles here. Tan 90 minus theta was cot theta. Cot we can again replace as 1 by tan theta because cot and tan are complementary angles. So we have the value of tan theta here. Substitute and then simplify.